All right. Yeah. First of all, thanks everyone also for being here. Probably some of you are from Vienna. I am Austrian, so for me it was a close ride. What I want to do today is, in the beginning, talk a little bit about myself, what I've been doing over the last few years, and also talk about Prior Labs and TabPFN particularly, which is our tabular foundation model. I just have this Kaggle profile of me up here because I think it summarizes quite a bit what I have been doing. Basically, I have been in data science, AI, I would say close to 15 years at this point. It was not even called data science back then, or maybe it started like 10 years around ago, where it was the sexiest job alive, right? Maybe this changed, I'm not sure. Yeah, started in the beginning with like the classical tabular models, decision trees and so on, and I did my PhD in the field. I then worked for an insurance company as a data scientist when I came back to Austria. Missed a little bit the competitive spirit of research and figured out, hey, Kaggle looks like an interesting place. This was particularly at the time when deep learning came up really to bring value in text data, computer vision data. And I started to do really well on Kaggle, particularly like computer vision, tabular, and text. And yeah, I got hooked, like probably many of you have been with Numere. I got hooked to Kaggle and competitive data science in general because I always found it fun to have something to measure yourself against, right? If you work in a company, you usually just compare to yourself in a way, right? You try to drive some KPIs, but there is no upper limit. And I think the nice thing with Kaggle and others is that you have like a real comparison of what your solution compares to the best people in the world. Or nowadays we might come to that to open cloud, right? Yeah, as you can see on Kaggle you can get gold medals, but you also can get a ranking. You get a grandmaster after a certain number of gold medals. Overall I have, anyways, 38 gold medals. I have been multiple times ranked 1 over the years. Now I don't spend that much time on Kaggle any longer, and I got a kid, maybe that's the reason. I'm 25 because your points decay over time and others catch up. That's the thing. But I have done a lot of competitions, and I never saw myself as someone that wants to only focus on one field, like only text. I always tried to get everything from all the different modalities, text, vision, tabular. And over the last few years, we have seen a lot of advancements in unstructured data, text, vision, speech, audio, etc. And I identified for myself that tabular is maybe a field that hasn't gotten so much love over the last few years, although it is so prominent in all the different companies for stuff like Numere, etc. Like tabular data is really the bread and butter. I never did Numere. Jo maybe recommended it to me many years ago. I'm not sure if I would be broke or rich now. I don't know, but Kaggle was kind of my thing. I worked for H2O for 5 years. That was my previous stint, and now for 3 months, actually only, or maybe even 4 at this point, I joined Prior Labs. And I joined Prior Labs particularly because, as I just mentioned, I think tabular data has a lot of opportunities. And Prior Labs is a German startup. They have offices in Freiburg and in Berlin. Now we are also opening one in New York. I'm traveling there next week actually. It all started with a paper in Nature by one of our founders, Noah, and it promoted this idea of also having foundation models for tabular data. So the idea is we take a similar concept as we have it for LLMs. You have a foundation model that you can just apply to the data, and I will get to that. And it was the first tabular foundation model, as I said, published in Nature. And it is SOTA for predictive modeling, classification, regression, causal and time series problems. We have an open source version of it, a repo. We have 3 million downloads, and I'm sure we will get to that to try it out. The idea is, as I mentioned, so with LLMs you have usually tasks over unstructured data, no matter the domain. So they excel at language, they excel at knowledge, summaries, explanations, particularly coding nowadays, and they can boost business productivity. And with structured data, like think about databases, CSVs, spreadsheets, tabular data frames, time series, etc., all that is tabular, we want to cover that and cover this prediction use case. So we want to excel at patterns, predictions, forecasts, scores, anomalies, and this is really a huge field. In the original or in the traditional way, when we think about tabular use cases, we usually think use case by use case, right? You have one use case, you train one specific model, you maybe do some XGBoost modeling, you train one model, and it really excels at this single use case. And with tabular foundation models, you have one model and you can apply it to whatever use case you want. It is agnostic to that. Of course, you can also tune it if you want to, but the idea is really you can start using the model out of the box. So, how is the high overview of training and inference for TabPFN? So first of all, it has been trained on hundreds of millions of synthetically generated tabular data. So it is a little bit similar to the large-scale pre-training we know from LLMs on text, but in this case it is pre-trained on large amounts of tabular data. And this is synthetic data generated from causal graphs. And through its pre-training, the model learns to generalize on any new data. And you still have this concept of you have training data with labels and you want to predict on unseen data, but it is now an in-context paradigm. So it means you just put in the training data set as a context, and the model can directly make predictions on the unseen data or on the X-test data based on the context data that is put in. But you don't need to train it in any way. You don't need to do hyperparameter training, you don't need to do anything on top. You can directly make predictions. So it's not like this, we heard about Optuna, hyperparameter tuning, sophisticated tuning mechanisms. You don't need to do that. You don't need AutoML, you don't need to do all of this stuff. You just have a data set with labels, you have TabPFN and you can make predictions. So it's still, we follow the typical scikit-learn API, right? It's literally these two lines, the data fit, there is no like training happening, it is just for providing the context of the data. There is like the one benefit is that you don't need to do the training, of course, so you can get instant accurate predictions. This is of course also very valuable for like live ongoing use cases, right? Where you don't even have time to train big models, but it is also very accurate, and I will get to that. It is also for faster deployment pipelines. You can skip the pre-processing. So for example, it can handle non-values out of the box. It can, we usually, like I have tried this many times now, you have some kind of messy data set, and usually people struggle to like, hey, now I need to one-hot encode this one, now I need to fill in the non-values here, now, oh, it doesn't run, right? And with TabPFN we are really trying to be super easy and flexible, data in, predictions out. And we are very data efficient, that means usually we need less data for similar accuracies. What would be the world without benchmarks, right? So in the tabular world, there is nowadays Tab Arena, which has been initially also started by the AutoClone team. If you know AutoClone, it's probably like one of the most popular AutoML libraries nowadays. And it is a benchmark across many, many different tabular data sets. And here you can see that TabPFN 2.5 here is at the front. Some autogluon ensembles would be a bit higher, right? But if you just compare all the different types of models, TabPFN 2.5 is here on top. TabPFN 2.5, this is really just the synthetically trained. We also have a version that is continue trained on some, not much, real data on top, and this is a bit better. Of course, we are also continuing to release new versions, so you can be sure that something new will come out at a certain point in the future. It's not only flat tabular tables that we are interested in, we are really interested in supporting all the different types of tabular data, either already now, like time series works already super well, but also like newer types of data in the future, like think about multi-table, think about grouped types of data sets, and more sophisticated time series. So we really want to be the go-stop model for any kind of tabular data, but even for time series, although it was not trained for a time series specific context, like some of these other models you might know, like Chronos and so on, it is already pretty well working on time series data. One big topic that we are also trying to, which is also a big research topic for us, is the whole topic about causal inference. We actually had, so if you're interested in this topic, we had a webinar 2 weeks ago where it was amazing, and you can check it out online, you will find it. But in principle, we are trying to also support causal inference out of the box with TabPFN. And we also have DoPFN, which was in Europe's 2025 spotlight paper from us, and it tries to also support this like causal what-if analysis. So it's not only always about prediction, right? We sometimes also want to like these interventional questions like what will the response be for this individual if I change this feature to a specific value. So that is just a side note here, because I know that this is a big topic in many companies. We also try to support like all these other things around the modeling, right? So interpretability. In general, we are doing very smooth predictions. So this is just an example with 2 classes, right? CatBoost usually does very like hard lines. That's the nature of tree models. And with neural networks in general, you can make smoother predictions. That can also help you definitely with more well-calibrated uncertainty estimates. I also talked about relational data, so this is also something where we already work very nicely with certain types of feature preparations, but we also want to more natively support this in the future. This is maybe not too relevant for this context, but just for you to know, we have these open source weights, you can use them. We also have we have a huge open source community. We have an extensions package also, which supports a lot of the things that you might want to do. We also have fun things like, maybe someone of you knows NanoGPT from Capafi, right? We have Nano TabPFN, so you can also speedrun your own kind of tabular foundation model training if you're curious. So we have a whole community about a lot of these things. Some of these we also, of course, have some commercial capabilities, but basically we have the open source weights available. I mentioned a few things of this, but in principle you can do classification regression use cases, but you can also do things like unsupervised anomaly detection, time series, interpretability. We have some support for text integrations. You can create tabular embeddings, right? Also something that can be quite usable. We can generate synthetic data, so you can actually use TabPFN to generate synthetic samples from your tabular data. We also have fine-tuning, if you're interested in that, and agentic stuff that I will talk on, of course. Agentic things a little bit later. And yeah, we are not focused on any kind of industry because tabular data is omnipresent. We focus on all the different fields. Yeah, I talked about, we also have an API that is actually, you can just sign up and use. So in general, a tabular foundation model is best used locally with a GPU. So if you don't have a GPU, we actually have an API that you can just sign up. There's some free credits there to use. And we run it on our infrastructure, and you can, it's really just an API endpoint that you can send data to, and you get predictions back. We also have an MCP. I will get to this afterwards. Yeah, so that said, with like, you have the model, right? You follow the standard paradigm of making predictions for tabular data, but you can also include these things into what I already teased a little bit into like agentic applications. So for now, including tabular predictions in agents is not a trivial thing, right? Specifically on like smaller scale setups. So think about you're asking your agent, it's maybe a boring use case, but what is the weather tomorrow, right? It will probably either do a web search or it will try to reason itself over some historic data and just look at some historic weather data and come up with a solution, but it is not naturally built for making this type of predictions. But now think about an agent that can pull up historic weather data through an API, for example, right? It pulls up, hey, this hour the weather was like this. Then you send it to TabPFN. TabPFN can naturally work with this tabular data and make clean prediction on whatever you're interested in. So really this like prediction as a service and combining and moving this into the agentic workflows. So yeah, I already mentioned this, like TabPFN gives AI agents the structured data intelligence they are sometimes missing. So the agent receives the task, the agent calls TabPFN, for example via MCP, API, or a coding agent could also just run it locally if it wants to. The agent reasons on the output, on the predictions, and gives me back an actionable insight. So you can even think of having this, we heard about N8N, for example, where you have like complex agentic pipelines, where sometimes even in an agentic pipeline you need to do decision making, right? What do I do next? So even for those use cases you can make more informed decisions with a tabular prediction. We have an MCP server, we have an API. The MCP works with every major LLM, of course, and it works something like this. So I'm not sure if you can play here. Oops, that was this one. Okay, not sure if it plays.
Can you try the spacebar? The spacebar, just press once.
No, then it goes to the next one.
Or just click in the middle.
I mean, I'm clicking on the play, right? But nothing happens.
Let me try.
Anyways, nee, dann geht er zum nächsten. Not too important. Yeah, so the idea is really like, also like, you know, right? You're sometimes it's playing. You're uploading a CSV file to Claude. You ask something about the CSV file, right? Claude looks at the data, comes up with something. But if you can combine this really with a prediction model out of the box, that where the agent really just picks the right data, right? Feeds it into, for example, TabPFN. That trains a model and makes a prediction that is pretty powerful. So this is just an example. If you would put some data into an agent and ask for predictions, what would the outcome be? The next one is you can of course also do fun stuff like this. So here you can see on the top I made the prompt playground series S5E3, which is a Kaggle playground competition. Get the data from this Kaggle competition, train TabPFN on rainfall targets, predict, test, and make a submission with probabilities and submit this to Kaggle, right? And this whole video runs, I think, 2 minutes. It uses the Kaggle MCP, it reads the description, it downloads the data, it prepares the data, it sends the data to TabPFN MCP. TabPFN trains the model, which is just a forward pass, right? No fancy hyperparameter optimization or loops are needed. It makes a prediction, gets it back. Claude takes the predictions, makes a nice CSV, uses again Kaggle MCP, makes the submission, and 2 minutes from this prompt, we can wait a minute, it makes the submission and you have a running submission. And I think stuff like this is also really powerful from what I heard earlier for like numeray skills, right? Numeray, auto-research kind of loops, where you can really plug this in and you can do very quick iterations and in the afternoon, in the workshop, we also want to look a little bit more into like feature engineering. So you can focus on different tasks of the data science pipeline, I would say, than just doing this like hyperparameter tuning. For example, also with like feature engineering, if you think about it, sometimes you add a new feature and you need to redo the hyperparameter tuning, right? And all of these things we try to avoid because it's just the model stays the same, and you can iterate stuff around the model. Yeah, we're nearly there. It makes a prediction. I pull up here. This was and you get the score. So yeah, I think these things are really powerful, and they are definitely here to stay and even advance over time. And we try either through MCP, but also through coding agents, of course, that can use this naturally out of the box to be in this whole agentic pipeline that is popping up. And as I mentioned before, I'm in data science for a long time, and I have seen the field evolve, but definitely over the last year, probably, months even, it has probably advanced the most, I would say, I have seen so far. And also happy to talk in general about how the field has evolved over time, specifically now with like auto research and so on. And yeah, it is an exciting time, I think. Okay, so yeah, that brings me already to the end of what I wanted to talk about. This is a high-level overview. Happy to answer any questions, and also happy to try it out in the afternoon. And yeah, thank you. Okay, any questions? I can choose. Let's start just in front.
Yeah, following TabPFN from back when it was an academic project in 2023. Although I checked out with the recent updates. So, in some ways, in-context learning is one of the biggest drives we've had in our field. side of that is that essentially attention infamously has a quadratic complexity. And there are certain limits. So I think back in the day, I think there were some limits around 100 features and 10,000 rows. It looks like you managed to scale it up.
Yeah, so in the current version that is like open, it is 500 features and 50 to 100k samples. Also where it is like very, very competitive to tree models. But we are currently scaling up, of course, it's not. I'm not the one making promises, right? But you can expect big scaling for some of the next versions. Yes, you're right. The normal attention is quadratic, right? And within context, you have these limitations. But there is a lot of research going on to be able to scale this.
Yeah, a follow-up question is: are you guys making attempts to linearize attention?
Yeah, I mean, I cannot say anything what is, but in general, like, I also want to emphasize we're publishing a lot, like, really a lot. Also, we have, like, one of our founders is Frank Hutter, some of you might have heard, right? He's kind of like the godfather of AutoML. And we're not doing AutoMLs, like, it's not AutoML, but we're publishing a lot. And if you just go through the list of what we publish, we also share a lot, and yeah.
Thank you.
Yeah.
So I understand that fine-tuning the model, the base model, would probably improve performance on the domain.
Yes.
But I see the result that you're showing, the benchmark. It looked like it was. I mean, I don't know what June meant there exactly, but it looked like it dropped performance. So do you have a reason for that? This is one of the first graphs that you showed.
Yeah, I know what you mean. This one. Yeah, actually tuned is not fine-tuned in this case. But it's yes, yeah. But it's
the same graph column.
Yeah. It's a good point. But in general, tuning improves it. But tuning means like some hyperparameter tuning. But it is not. It doesn't have this leverage that it has for like GBM, right? There you need to do it. Here it's usually just trying a few different checkpoints and doing a little bit pre-processing differently. But you can also fine-tune, and fine-tune has also leverage on top.
I understood that the open source version is not usable for commercial applications.
Yes.
It's very installable. Is there next to the API that you can consume also a possibility to use models on home infrastructure?
Yes. So we definitely deploy on-premise. We deploy in all the big cloud providers. We even have marketplace offerings in some of them. We are definitely trying to also advance that. But in general, for any kind of commercial application, it's absolutely possible to run this on site in a container in whatever form and have it available. Yes.
How do you deal with the compliance tsunami which is coming?
Which one exactly?
Yeah, like liabilities for the AI deployers and those kind of things.
That's not my question to answer, but I mean, I'm not sure what you're particularly referring to now, but yeah.
I think a lot of the American states and European states are going to be mandating explainability.
Explainability, auditability, transparency, how it came to this decision.
Yeah, I mean, I already mentioned that, right? So that is one strength that we have directly built in certain explainability capabilities. So think about similar to Sharp and Co, right? So that is definitely one area. We also give like, so for example, for regression, and not every model can do that. We have out-of-the-box confidence predictions, right? So we have like quantiles, you can get the whole distribution out. It's basically a posterior predictive distribution, right? So you don't only get a point estimate, you get like the whole confidence, which already boosts this kind of like confidence in the outputs. Yeah, so all of those things we're trying to put into the model capabilities natively.
You talked a lot about the advantages, and it sounded a bit like it's going to replace all the traditional.
Yeah.
But I'm sure there are some disadvantages, and are there
Yes.
some situations where you would still use like traditional?
Yes. So in general, like it works very, very strongly out of the box for data, I would say, below this 50,000 range samples at the moment. If it's like super large scale data, where you can train an XGBoost model to the last digit nicely, right? You will be able to probably perform better, right? But in general, like if we then talk about ensembling, it has its place in the big ensembles again, right? So I think it's often on smaller data and like in this range of these TabArena data sets. You can see here it up to 100K training rows and 2K features. It performs really good, the best. And otherwise, I would see it also as another thing to use and try, right? But we are definitely scaling up, and we also definitely will or want to be the best model on all modalities of tabular data. Yeah. Mm-hmm.
Thank you for the nice presentation. I think for a prediction it sounds fine. With causal inference, I would say just because something can do it, it shouldn't really do it. Because in causal inference, currently the state-of-the-art practices is that you really look into what data you put in the model. Mostly it's not about the model you apply in the end, but it's the data. And with your approach, I would be worried that you maybe mix timelines, because with causal inference, the gold standard is clinical trials, where you look at both groups, both the placebo group and maybe the group where you apply certain medication should be similar, and then you go forward. So currently, the go-to are target trials. You try to emulate the target trial as much as possible, and then you get treatment effect, you can evaluate it. Here you would basically get predictions, and I say if I don't have any sort of evaluation how good this model is in terms of maybe you have any benchmarks that you already tried it in the causal inference context and you saw, okay, with the clinical trials you saw the same treatment effect, the same confidence intervals, or do you have any views?
So first of all, it's not my core topic, but we have this TabPFN paper. Please check it out. I don't have any benchmarks here, but we will also release TabPFN this year, which is kind of our causal model. We don't want it to only work on such data. We also want to work it on observational data, right? I mean, we're talking about the classical S learners, T learners, right? And it works. I don't have any benchmarks to show you here now, but it works very competitive and very strong. We can also talk afterwards, and I can show you some results from the paper. Yeah, I mean, it's a very fine granular field, the whole causal topic, right? Because as you mentioned, data is kind of plays a big role. But when you have certain data sets, and we have seen this also in many use cases that we are running, in general it performs at least on par and better than existing approaches for this.
Okay, just one question. Last question to you. You guys looked into auto ensemble?
Which one?
Have you guys looked into auto ensemble?
Auto ensemble?
Yeah.
Like in general auto ensembling or like?
Automatic ensembling of different models.
Yeah. So first of all, we are integrated into AutoGluon, right? So if you run AutoGluon on like the newest versions, right, it will also run TabPFN and also try to automatically ensemble TabPFN in the big like ensembles that it is doing. And there it usually plays definitely a significant role. I mean, as we know from Kaggle, right, historically always it was the strongest in tabular competitions to ensemble neural nets with tree-based models. Usually those were like custom-built neural nets, but now these get replaced by tabular foundation models, which are also neural nets, right? And so it ensembles very, very well with tree-based models in general.